to Algebra 2. Hope you guys are having a great day. It's very cold outside. I don't like it. But I hope you are all warm. And maybe when you're watching this, it actually is warm. So, you know, that's the awkward thing about these videos. Anyways, this is not 331. This is 332. Sorry, my bad. Anyways, okay. So we're doing 332, which is dividing polynomials with synthetic division. We've already done long division, okay? And long division always works, okay? Synthetic division I teach to you, it doesn't always work. It works on only certain cases, but it's a lot faster than long division. So I teach it to you because if you have the case where it works, you should definitely use it just because it's faster. But if you don't want to and you don't like synthetic division, you can always use long division, okay? So we are going to divide polynomials with synthetic division, and then we're also going to use the remainder theorem to determine the remainder of a quotient. So here we go. Synthetic division is a shortcut to long division, but the only problem is that it can only be used if you're dividing by x plus or minus a constant, okay? And what that looks like, I'm going to write it like this. Here, I will show you. I'm going to write it as x minus c, okay, where c is a constant, but it can be positive or negative, right? So where c is a constant, okay, and remember constant is just a number, okay, but keep in mind if c is -2, then that's going to be x minus -2, which is x plus 2. So you'll actually see it as x plus 2, but x minus c. So if c is positive 2, then it's x minus 2, so c is 2. Okay, so anyways, just wanted you to know that. Okay, so here's the process. All right, you make like a division sign that's upside down, or like not a division sign, but you know, the thing that you normally use to divide, and make it upside down, like that, okay? Usually it's that, so you flip it, okay? And then the number c, remember x minus c, so if it's x plus 2, c is -2. So you put c out here, and you draw another line there. And then in the top part here, what you're going to put is all of the coefficients of the polynomial that you're dividing, okay? The polynomial you're dividing into. Okay, so the purple is your setup, all right? And then the process is you take each coefficient and you add down. So you add down, okay? So, and I'll show you an example so it'll make more sense. Okay, and then here you multiply whatever this number is, you multiply by c, and then put it here, and then you add down again, okay? Okay, so you repeat this process until you can't do it anymore, okay? The answer, so all of the numbers that are down here are going to be the coefficients of your quotient, okay? And because you're taking a polynomial and dividing it by x, the new polynomial that is your answer is going to start with 1 degree less than your starting polynomial. So if the polynomial that you put up here was x to the 5th, right, it was a 5th degree polynomial, your answer is going to start with x to the 4th. Okay. Also, I didn't specify this, but they have to be in standard form. So you have to start in standard form, and your answer is going to be standard form as well. And the really nice thing is that the last number, okay, so at the end you're going to get a bunch of numbers down here, and then the last number is your remainder. Okay, it'll make more sense when we do an example. Okay, so let's do example number 1 together. And then I'm going to let you try example 2 by yourself, and then I'll show you the steps. But the kicker with example 2, so when you actually try it, is that you have an x to the 4th, and then it jumps to x to the first. You need to have zeros as placeholders when you're doing synthetic division especially. Otherwise you won't get the right answer. So you would need the coefficients of x to the third and x squared as well when you're synthetically dividing. Okay, otherwise you won't get the right answer. Okay, let's try example 1. So example 1, you have x squared minus 2x plus 3 divided by x minus 2. Keep in mind, right, you are dividing by x minus a number, or x plus a number, but, and so you can do synthetic division. So you always want to check that first before you jump into synthetic division. Okay, so you set up your upside down division sign. You put the coefficients of the polynomial you're dividing, so the dividend, and you put those coefficients in the box. So we do 1, -2, and 3. Okay, and then c goes out here. That's where c goes. And in this case, x minus c, so c is positive 2, not negative 2. Okay? Okay, so then we draw our line here. And then we just start adding down and multiplying across. So I add down, starting from left to right. 1 plus nothing is just 1. And then I take that 1 and I multiply it by c to get this next number here. So 1 times 2, right? 1 times 2 is 2. So then I add down again. -2 plus 2 is 0. And then I take 0 and multiply by c, which is 0. And then add down for the last one is 3. So what I was saying before is that all of the terms except for the last one are the coefficients of your answer. Okay, so this was x squared minus 2x plus 3. 1 and 0 are your coefficients of your answer, and it always starts 1 degree less than what you started with. So I started with an x squared, so my final answer is going to start with degree 1 instead of 2. Okay, so this 1 actually is the 1 in front of x plus 0. Okay, and that's where you get the 0. Okay, because I'm going down in degrees. And then that 3 is my remainder. Okay, so this guy's my remainder. And we write the remainder the same way we wrote the remainder with long division. So we do plus 3 over whatever the divisor was, x minus 2. Okay, so my final answer is x plus 3 over x minus 2. Okay, go ahead, try example 2. So just for a moment here, ignore the second part of the question. So just try example number 2 first, and then I'll put the answer and explain, the process. Go ahead, try it. Okay, so here's the setup. Remember what I said about placeholders for the x to the third and x squared. So this is 1x to the fourth plus 0x cubed plus 0x squared minus 5x plus 10. Okay, so those are all my coefficients. And then c in this case is -3 because it's x plus 3, so x minus -3. So -3 is your c value. And then you just do the process. Add down, multiply, add down, multiply, add down, multiply. Okay, so I will do that and go ahead, check your answer. Okay, so add down, multiply by -3, 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 add down, and you end up with 1, -3, 9, -32, and 106. Okay, this wasn't necessarily a nice problem, but it's easy with synthetic division. So your original problem was you started with x to the fourth. Okay, so your answer starts with 1 degree less than 4. Okay, so I started with the 4th degree, my answer has the 3rd degree, so I have 1x cubed minus 3x squared plus 9x minus 32, and then that 106 is my remainder, 106 over x plus 3. Okay, so go ahead and try the second part of each problem, and if you'll notice, so sorry, there was a typo, so the x squared, it actually should be x squared, not x cubed, but notice that we're actually taking the same polynomial, and instead of dividing it by x minus 2, we're taking whatever c was, and we're plugging it into the function, okay? And then the same thing here, we're taking the dividend and plugging in whatever c was, right? In this case, c is -3. We're plugging it in for x. So go ahead, try that, and see what you get. So notice that when you plug c in to the polynomial, you actually end up with whatever your remainder was. So 106, 106, 3, and 3. So that's our last theorem for the day, which is called the remainder theorem. And basically all it says is that if you are dividing a polynomial by x minus c, then the remainder, when you divide them, is equal to the same number as if you were to plug c into the polynomial. So that's fun. So that's what the remainder theorem looks like. So if a polynomial p of x is divided by x minus c, then the remainder is p of c. Okay, so you've got this example here, example 3. This is without actually dividing. Find the remainder of the following quotient. So I could divide, right? I could use synthetic division in this case because I just have x minus c is my divisor. But in this case it says don't actually divide it out. So I'm going to use the remainder theorem, and the remainder theorem says that the remainder is going to be the number when I take c. So in this case, x minus c is x minus -5. So c is -5, right? Because it's x plus 5 there. So c is -5. So if I take -5 and I plug it into the original polynomial, which is that x squared minus 2x plus 3, if I plug that in, I'm going to get the remainder. So I can just take that polynomial, plug a -5 in. So p of x is x squared minus 2x plus 3. And I'm going to take c, which is -5, and just plug it into the polynomial. So p of -5 is going to be -5 squared minus 2 times -5 plus 3, which is 25 plus 10 plus 3, which is 38. Now if you want to double check that, so the remainder is that 38. Okay, but if you wanted to double check that, you could use synthetic division or you could use long division. And I did the synthetic division down here just to check. Plugged in my coefficients, added down. Here are my coefficients. Here's my c, which is -5. I add down, multiplied by c, add down, multiplied by c, add down. And I still get that my remainder is 38. So this doesn't seem that exciting right now, but it's actually a really, really fast way to check and see if this term, if x plus 5, goes into x squared minus 2x plus 3 evenly, right? If it goes in evenly, it should have what kind of a remainder? No remainder, right? And so if I can figure out if I plug in c, -5, and I get 0 as the remainder, then I know that it went in evenly. And that's a really, really, really nice thing for us to know later on in the future. So this is a helpful theorem. Yay! Okay, that's all. Have a nice day. Bye-bye.